Hello, everyone. Welcome again to Powering Up Your Formulations podcast, sponsored by BASF Performance and Formulations Additives. My name is Loy Angeles, your host and Global Additives Industry Marketing Manager in North America. I'm excited because this is our first episode of the year, and my guest and I will talk about a fantastic topic today. But before to start, and for those who haven't listened us before, let me share. In this podcast, my guests and I used to dive into the world of paints and coatings formulations, from an understanding the chemistry behind their essential raw materials to exploring innovative and sustainable products. We uncovered the secrets behind creating vibrant paints, durable finishes, and environmentally friendly coatings. So please join us and find the latest episodes in our BSF YouTube channel. We as an additives are ready to hand in hand with our customers to powering up their formulations and really provide the best solutions for the next level of the high performance coatings. Okay, so let's start. Today, I have the pleasure to introduce my colleague, John Mangano. He is our technical service specialist within the BASF Formulations Additives Group in North America. His responsibility is our Defoamer product line and supports the architectural coatings market. John has been in this technical role for 17 years. Prior to that, he accumulated 27 years in coatings formulation and development working in both industrial maintenance coatings and architectural coatings. Hi, John. Welcome again to this podcast.
Hello, Louis, and thank you for inviting me. It's a pleasure to be here, and I welcome our audience to this podcast and hope you find it beneficial. So thank you.
Yeah, no, thanks to you, John. So, you and I know very well that BASF is a premier provider of performance and formulations additives for the paints and coatings industry. Our portfolio has a comprehensive range of respected brands and broad technology base of product lines. On today's episode, we will have an exciting conversation about defoamers. And I would like to highlight that BASF offers a broad defoamer portfolio for water-based systems, including products based on mineral oils, natural oils, aqueous emulsions, silicones, and other polymers. But today, we will focus on a comparison between our mineral oil and star-polymer based defoamers. But before to start, I think it is important that our audience understand basic concepts. And I would like you to explain to us what is foam, John.
Well, Louis, foam is air that has been mixed into the liquid material, and it's stabilized. So when air is mixed into pure liquids, there's no stabilization of that air, and it escapes freely and uninhibited. In a coating, however, due to the general composition of how to make a water-based or emulsion or latex type coating, just the aspect of needing to bring an oil-water mixture to a stabilizing aspect for the coating creates a scenario where when the air is mixed into the coating, it is stabilized in there and thus retarded from escaping. And thus creates the need for the defoamer actives in the formulation.
Thank you, John. Great explanation. So, um, I think, since you already explained what is foam, I will say, based on your explanation, definitely foam, it is a very undesired phenomenon. And I think, in most of the industrial process, like stirring, mixing, milling, or spraying, we don't want to see foam. So we need to avoid this effect. Just for example, like in the video, we are seeing how the foam looks. And I certain that based on our formulations additives, and in particular based on our defoamers, we can solve these issues. So, and then we do this in the paints and in the coatings, and I think, well, if we try to understand the beauty of this word, I think thinking about the defoamer nomenclature, well, it is very probably it could be unclear and sometimes difficult to digest because, well, we have defoamers, we have antifoams, we have directors. So if I try to explain what is a defoamer, well, I think it is typically defined as a product which destroys existing foam, a no-don't effect, whereas antifoams are defined as products which prevent the formation of foam, and derators or air release agents, on the other hand, are designed to remove micro air bubbles or microfoam from a formulation. So I think since all the defoaming products are not exclusively an antifoam or exclusively a deaerator, but they are all of kind of mix of dimension product types. So I think for reason of simplicity, let's talk about defoamers today. So John, I did I do the distinction properly, or could you like to add anything from your end?
No, Louis, you did an excellent job of distincting the nomenclature. And it is critical to understand that while a defoamer, anti-foam deaerator might be focused on a certain aspect of where the foam is created, for example, an anti-foam you might think about using in the grind phase as you have that high energy mixing and you want to prevent the foam formation in the beginning, in the first place. But the products all work in all three phases. So an anti-foam will still have some deaerating and defoaming activity, just as a defoamer will have some anti-foam and deaerating activity. The other aspect I would say about these terms is you see it used differently by the markets. You see the terms anti-foam and deaerators heavily used in the industrial market, while in the architectural market, the term defoamers is the dominant nomenclature used.
Excellent. Thank you for your comments, John. So where the formulators are making a coating, I think it is important to talk about why it is important to talk about defoamers. I mean, here we have three important questions that I appreciate that you helped me to answer, because I believe based on these three ask, the formulators can learn more about this defoamers world. So if we start with these three questions: where does foam comes from, which features should a defoamer have, and if we choose the best one, what will happen? I mean, what you can explain about these three questions, John?
So where does foam come from? Foam will be created anytime you're adding energy into the liquid coating. So is it in the dispersion phase, the pumping phase, stirring phase, and application phase? You're adding energy at those points, and so you're mixing air into the system, which will create foam. What does a defoamer have to do? It has to be efficient. The other aspect is incorporation. Now, incorporation changes depending on the point of addition. So incorporation at the dispersion or grinding phase is a lot more energy than incorporation, say, if you needed to post-add it in your finishing tank, where your mixing may not be as strong. So that's an aspect you need to keep in mind as you're selecting your defoamer. The long-term effectiveness and the compatibility kind of go hand in hand because they work against each other in terms that the stronger the defoamer, the less compatible it would be, so more prone to film defects. While if you get something very compatible, then defoaming effectiveness and efficiency will be reduced. How do we choose the best one? Testing. We can make our best guesses from the list. We can look at the products, understand are they used in high shear environments, low shear environments, easy to incorporate, more difficult to incorporate. But basically, we have to test to determine what's going to be the best. And when we find the right one, it helps the overall production. It can improve our dispersion efficiency by removing the air, and since dispersion is predominantly occurred by pigment-to-pigment impact, we're increasing that efficiency of that impact. Plus, on the filling aspect, the worst case scenario of foam is foam in the filling process. Your can overflows, so you can't accurately fill. So if we reduce the foam, now you can accurately fill your cans. So those are some concepts of how you pick a defoamer and what its performance aspects are.
Thank you, John. And well, now that you have helped me to navigate in the world of defoamers, I would like to bring to our discussion the key topic today. So as I mentioned before, the defoamers product range for water-based coatings means a lot of products. So I think if we only focus on these three categories or these three technologies-based defoamers, and why we would like to discuss about the mineral oil and the oil base and do a comparison against our star polymers and silicon base. Well, we have identified as a market need that the customers are looking for a consolidation of raw materials in the coatings industry. These three technologies can meet this market need. So we understand that the defoamer selection process, based on your prior explanations, depends on different aspects. And I think testing it is important. But if at the end we focus on the multiple effects or the multiple things to consider in the selection of the defoamers, why should customers think about these three chemistries?
So, Louis, oil-based is your basic standard, I'd say, long-term technology of defoaming actives, especially for waterborne coatings. As formulations have changed, however, defoaming has become more difficult, and so you've needed to get stronger products to be effective, efficient, plus faster acting, since paints are curing and drying so fast that it gives less time for the defoaming activity to have full impact and effect. And that's then where the Star-polymer comes in. The Star-polymer is actually a defoaming active that is used in combination with other defoaming ingredients to act synergistically to improve the overall defoaming speed and effectiveness of the product. So you're moving up in technology, you're moving up in performance, while still retaining a lot of the characteristics that can be seen in the oil-based area. When you go to the silicone-based, basically silicone can be used everywhere. It's a great defoaming active. It's a very effective defoaming active. It's also very high priced. And there's nothing, that's the cost of silicone. Why would you not use mineral oil and mineral oil stars across the board? Because as you get into the medium to high gloss coatings, the oil will cause a haze in the system. If you have a clear coat, it could haze it and make it not as transparent. That's where then you need the silicone chemistry, because that will have better compatibility in the overall system, in essence, and it will maintain film clarity. It maintains high gloss within the finish. Understand all the defoaming types can effectively defoam across the gloss range and a gloss formulation type. So your chemistry then leads to what is the gloss, what is the clarity in the film you need. And if you need a really true high gloss clear, the silicone chemistry becomes a preferred chemistry.
Thank you, John. I really like how you explained these three types of defoamers, because you also cover the technical advantage of each product range. So I think really appreciate your insights here, because I think based on your comments, the formulators can understand how they can use or how they can prioritize between these three types of defoamers. So if I at the end, if we would like to go more deeply in this discussion, I think, well, I would like to highlight that between the mineral oil defoamers and the Star-polymer defoamers, to do easier the selection process, here we only see five products. Two mineral oils, the Fomaster MO2152 and the MO2133. So these two are non-dispersible mineral oil products, where the type of shear is needed high shear. And on the other hand, we have the star-based products that we are talking about, the 2410, the 2412, and the 2420. If the formulators could like to understand, based on this chart, which type of clothes they can achieve, and also the system for these kind of technologies are developed, what you can highlight about these five products?
So there are no hard and fast rules, but I would say from experience, the Fomaster MO products will detract about 5 to 10 points of gloss in your coating, depending on use level of the defoamer that is needed. So when can you not give up those 5 to 10 points of gloss? I think that's the bigger question. And typically that starts if your paints are getting to a gloss range of about 45 to 50. The Star Active component used in the products extends that range a little bit, because the Star Active helps to make the defoamer more compatible, even while it's making the defoamer more effective and more efficient. So we can extend the use in that gloss range, maybe up to about 55, 60, even though higher than that, yes, you'll still see some negative impact on gloss. And then when you get above that, if that gloss loss is still an issue, then you see the two top products in the upper right hand, the ED2528 and the SI2281, which are very compatible silicone defoamers, which would be used to not impact your gloss aspects. And so you'd have to make the switch to the silicone family. So I think that's what the Star Active gives you. It improves the overall defoaming efficiency while extending the gloss range that make the products are usable in.
Thank you, John. Okay, so I think, to me, it was important that you explained us the difference between these products, because at the end, as I mentioned minutes ago, really the market trend that we have seen in the industry, the consolidation of raw materials. So I think that it is helpful that you have provided the technology advantages of these products. And then if I try to summarize based on your explanation, and also the distinction between these products, well, I will encourage our audience, and mainly our formulators that are listening us, that I think it would be great if they focus on the two mineral oils, the 2152, the 2133, but also they don't forget the Star-polymer defoamer, the 2420. So as you can see, well, I think in the mineral oils defoamers, we can find an efficient and economical defoaming product range. There is a broad spectrum in terms of the application. On the other hand, in the Star-polymers, as you highlighted, so I think this is an outstanding performance portfolio that really can offer us an excellent cost in use, because even the highest price that probably we can have in the Star-polymers, at the end, we can mention that at equal dosage, the customers can get better performance. So I think if we combine the outstanding performance of these Star-polymers and the cost in use, well, definitely the formulators can get a lot of benefits of using these products. But yeah, the mineral oils, I think these are workhorse solutions for the coatings industry. So thank you for your explanation, John. I mean, I don't know if you want to say anything else about these three products, something that I maybe missed.
No, I think you summed it up very nice, Lewis. And yes, the mineral oils are workhorse and had been workhorse products. The only thing I would say from my experience is that as the formulations have changed, VOCs have dropped, surfactant usage has become more varied. Defoaming has become more of a problem, and the star-based products have become a very dominant class of defoaming materials because they are effective and cost of use is not that much greater than a standard commodity mineral oil type product.
Thank you, John. Thank you so much. I really appreciate that you joined me. Thanks again for coming. And well, I encourage all our listeners to reach us using our email address or writing to formulation-additives-nafta@bsf.com. Please also visit our website, bsf.us/dp solutions. We will be happy to provide samples or any additional technical assistance on our products. So saying that, I would just like to close and say thank you to my guests. I
Pleasure.
hope the audience really enjoyed the content. And so thanks again, John.
And again, thank you for inviting me. It's my pleasure to be here.